Hello and welcome to the C++ 11 Beginner Tutorials by Gamer2Creator. I'm Chris. So we've talked about string, and now we get to talk about vector. These are two classes that share a similar interface because they actually do two similar things. The string is a dynamic array of characters, but it also kind of has some specialized meaning because you'll often want to do things such as concatenate, search for a substring, get a C string, things like this, things that you would really only associate with arrays of characters and strings. But a vector is fun. I've been looking forward to this class. It is a template class. So this is the first time we're going to talk about templates. Now I'm not going to show you how to write a template class. Not yet anyway. But I am going to show you how to use a template class, and that'll be enough for now. So we need to include vector. Now don't get vector confused with the idea of like a two-dimensional mathematic vector or a 3D vector. Those are a mathematics thing. This is a dynamic array, and it's templated so you can make an array of anything. Now real quick, I'm going to do a quick refresher on arrays. Here we have an int, my int array, and we're going to make it 10, and there you go. We've created an array of 10 ints. We can access them by going my array 0, and for example I'll print it out on each line. I don't know why I did that. It should be a 1. Now this array is constant sized. This size is known at compile time, and it will never change. You can't make this any bigger, at least not after you've compiled it, such as runtime. So if you wanted to change it, you would have to come in here and go, okay, I want this to be 15, and then recompile, and then for anytime you run that application, it'll always be 15 unless you recompile it. Now a vector actually uses an array, but it puts it on the heap, and it does that with dynamic memory. And this is something that we haven't done ourselves just yet, but I want to show you a class that does it and provides a very simple interface. And then later on we'll actually cover doing that ourselves. Now vector should be, anytime you need an array of something that is dynamically sized, just use vector. That's what it's for. Sort of a general purpose data type. The only time that you would not use a vector is if you have very big data types, and a lot of them. As there was a, on isocpp.org, there was a great article, and a guy did all kinds of benchmarks of the different data types and collections, containers in the STL, and vector outperformed, because it's an array and the memory is sequential. It outperformed the list and the map by pretty good margin, until the data size for each variable in the array was up around like 1,000 or a kilobyte or 1,000 bytes each, and there was 1,000 of them or more. So you're talking about like megabytes of information in your array, and that's how much information in your array there has to be before you might want to think about using another data type. Now that's not going to be very often, and especially not as a beginner. So just think of vector as your basic container. This is what you're going to go to most of the time. Some of the others have some advanced functionality, and they store their information differently. And so you can do some searching on your own and pick the right one for you. But like I said, usually it will be vector. Alright, so let's move on. So we can make a vector of ints. We'll call it my int vec for my int vector. And we'll just end it with a semicolon. So now we have our vector of ints, and this is what a template looks like. You got the two arrows, left and right, and then the type in between. Now this is where you can put any type, whatever type you want your array to be of. I can have int, float, player. As you can see, because we've defined the player up above, this will actually compile. So this is valid. But for our first vector, we're going to use int. And this is how you use a template class. It's pretty simple. And this is the entire name of this class. This is a separate class than this. This is the fully qualified name if we added the std. Okay, but we don't need this because we're doing the using namespace std. Now, we want to add some ints to this vector, and therefore to our array. So we do my int vec dot, and you're gonna see this yet again, push back. We saw this with string. And like I said, these two share a similar interface. And then you can put in an integer. You can either put the literal 100 as my integer, or you can pass it a variable. It will copy this and stick it into the array. Now, you can do this as many times as you wish. We'll make this 1200. And we'll just print my int vec dot. We're going to use the array index, which you can do with vectors, since it is underlying an array, and they overloaded the bracket operator. So what we've done here, we've called pushback on our my int vector, and we've copied these two and stuffed them into the array. Now we're going to print out the first one and the second one. And you'll see it in action. So there you go. But a very handy way to do this is, let's create a variable. We're going to say we want int numbers equals 20. And we're just doing this so that our 20 has a variable name. We're going to loop over for int I equals 0, I is less than, and here we have another function, int vec dot size. We did this with the string. This is how many objects are currently active in our vector. Not the capacity of the vector, but how many we're actually using. ++I. Now here we can actually loop over it and print out my int vec I on in line. So we can get rid of these two lines down here. Now for example, a nice way to fill in our vector with some values is to do another loop, and we're going to do numbers. This is going to be an S ++I. So it's the same as if I just did 20, because that's the value of numbers. But instead of just having that literal 20, we have something that's a little bit more descriptive, and that's numbers. Or number count is a good way to do this. It's a little bit more descriptive. And then we're going to fill these with a random int. Sorry if I'm jumping around a lot. So we need to call srand time 0. We've talked about this in an earlier video. This gets us the seeded, this seeds our random number generator. And now we can use rand. So we'll do my int vec dot pushback, and we'll use the rand function. And remember, this returns an int between 0 and rand max, which is somewhere about 35,000 or something. So this first loop is going to loop 20 times, and each time it's going to push back a new random integer into our vector. In the next loop, we're going to loop through, and we're going to use the size here, the method size, to loop over this vector for each item in the vector, and we're going to print it out. And that's the end of the program. So as you can see, the end result is that we've printed out 20 random numbers. As you can see, I don't see any that are bigger than 35,000. Some that are close. And there you go. You know what, just for fun, I'm tired of wondering what this is. So, count, rand, max, and 1. So it looks like it's 32,767. So there were some that were very close, like this one. Anyway, so there you go. That's what rand max actually is. Alright, so now that you've seen pushback, you've seen that we can use the index operator, and we can use this to loop over for each one. Let's show you some more stuff. One thing I want to do, and this is going to be our very first C++ 11 feature. I'm going to show you the brand new way of looping over an STL vector, or an STD vector, however you want to say it. So we already have our vector, right? And we've already filled it with random values. And here we use the old way of doing it, which is still in use today. I'm going to show you the new way for int reference index my int vec. This is called a C++ for each loop. This is a reference. We haven't covered references yet, but it is what it sounds like. It's a reference to another object. Now, this is going to loop over each one of the ints in our vector. So we can print them out just like we did before, except for we use our variable that we created here, our reference variable. And this is going to go for each integer in my int vec loop. And this is the variable that we can use as our index. So this is going to be a reference to the integer within the my int vec. And then if we make this, index and line, this is going to do the exact same thing. Here we have 20 printed out plus rand max down at the bottom. So this is how you do a C++ 11 for loop. Now if we didn't make this a reference, it'll still work and it'll still output the same results. However, it will have copied the integer at the index that we're looping. And that is what we're going to use, instead of a reference to the actual object inside of the array. Again, references will be covered in depth in a later article or lesson. Alright, so we have our reference, we printed it out. Now with all this code, we can actually change to floats. And then here, what we're gonna do, instead of using a random value, we're gonna take our index integer, which will be 0, then 1, then 2, and 3, and 4, convert it into a float, and push that back. Then here we need to change this to a float. So we'll have our index to a float, and it'll be a reference. We'll print that out. As you can see, it prints out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 all the way to 19. So that is using a float. Now, like I said, you can use any type you want in here. We can use players, but we should probably change the name, my PlayerVect. We're going to lower this because there's a lot more information. Let's just do 5. And a player. Not that we're going to run out of space, it's just that I don't want to have to type in all that stuff. So now we need to push back a player, and we'll make it temporary using the constructor. And if I remember correctly, it needs 2 floats or a string and 2 floats. So let's just use this constructor with 2 floats, and we'll do the same thing. Float I, and then float I times I. So we'll have the float, and then we'll have it squared. And we need to change this to our PlayerVect. And we're just doing this because I chose to give it a more descriptive name now that we're using players. And we need to make this a player. And again, remember, we don't need the reference, but it will be a copy of the object at this index. With this, it's not a copy. Alright. And now Count doesn't know how to print a player, so we'd have to do index dot and index dot y. And we'll separate these by a space. And what did I forget? Oh, forgot parentheses. Alright, and we don't need this anymore. Alright, so what we're doing here is really conceptually pretty simple. We're creating our vector of players, which is an array. We've called it myPlayerVec. We're looping over this many times, which right now is 5. So for 5 times we're pushing back a new player at these coordinates. This one would be x, so it'll be I, and then y will be I times I. And then for each player in this vector, we're going to print out as x and y. And I forgot that the detour stuff is in there, but there you go. 0, 0, 0, 1, and then you have them squared. Let me go ahead and clean that up. Remove this text. That was text from our destructor, from the destructor lesson. so I removed it from employee 2 just in case you missed that. So our player and employee no longer print out that they had called their destructor. And we have what we expected. Now, actually that might be a pretty good example, because I want to show you a function called PlayerVect. Now in order to do pushback, we had to have a player variable to pass into it. Now if you can read this template code, it requires a player as its parameter. And to do that, we had to create a temp array, which means this player had to be constructed, copied, and then destructed, and the copy ends up in the vector. Now this is another new C++ feature. It's called PlayerVect.emplaceBack. Now instead of this, will do conceptually the same thing. It's adding to the end of the array another player. Only instead of taking in a player, it takes in the parameter list to the constructor that you want called, and then it constructs your player in the array directly. So you skip a copy operation and a temporary. So this is much faster. I'm going to go ahead and put player back in here so you can just see the difference. Just put 1.0f. So let me just say that again. The pushback requires that somewhere that you already have a player, either you temporarily construct one or you have a variable out here that you then send in. And of course, since it's an object, it must be constructed and destructed at some point. And that it's then copied and then placed into the vector. And PlayerVect takes in the parameters to your constructor for your player class, because that's the type of vector we're using, is a vector of player. And it will construct that player in the vector at the back. So this is much more efficient. It's a pretty handy function, and it's brand new for C++ 11. Now I want to point out there's also my PlayerVect.emplace. Now this actually requires that you send in an iterator for the position that you wish to add this in. So if you wanted to put it at like the 5th index, you'd have to get an iterator to that index, which I'll cover that in a minute, iterators, to tell it where to add it in, and then you'd add in your player as the next parameter. Now, since we don't have an iterator right now, I can't show you this just yet. But it's important to know that pushing or emplacing to the back of a vector is the most efficient place to add something into a vector. This is because you won't have to move any other objects. But if you were to try to move or place an object into the center of your vector, then all of the objects after that position will have to be moved down one space. But if you put it on the end, on the back, then there's nothing that needs to be moved. You just put your object on the end of the array. Now if the array doesn't have enough space for another object, then the vector will take care of managing that memory and make you a new array that's big enough, plus probably a little extra room for growth. And it will do all of that for you automatically, and that's why it's so nice to have this vector class. So remember that pushing to the back of an array or vector is the most efficient way of adding to a array or vector. Now there's also my PlayerVect dot, and we have the PopBack and pushback methods. We just talked about pushback. You can also remove the last one on the array. Now this is also the most efficient way to remove one from an array, because the one on the end, when you remove it, the size just is one less. If you had 5 objects, you now have 4, and that's it. But if you were to remove the one in the middle, then all the objects after it must be moved down 1 towards the front of the array, so that you don't have a gap, because you can't just have one of your objects that's not being used in the middle of your array. So sometimes you might want to swap the one you want to delete with the one on the end and then pop back. But that's kind of an advanced thing, and that is more efficient. Okay, so what else do we need? We have the capacity. We understand that capacity returns how big the array actually is. And I'm going to move what I'm doing up here. And again, you can use @ to get one of the objects at a particular index. You can erase a particular object. This requires the use of an iterator. We'll cover that in just a minute. You can check if this is empty. This is really good to do, because you could skip this entire loop by checking, well, is it empty? And if it's empty, then I don't need to do anything to this. And as you can tell, string and vector look a lot alike. Okay, so we've covered vector. Now we can also we can clear the entire vector. All the objects in this vector will have their destructors called, and the size will be set to 0. However, remember that the actual memory that this vector has allocated for the array will not be freed until its destructors run when it falls out of scope. So let's go right here, and we get here. We're going to stop the program, and we're going to look at PlayerVect. As you can see, since we have called clear, the size is 0. There's nothing being used in this array, but the capacity of the underlying buffer is 6. And somewhere in here is the actual array. Anyway. Okay. So I think we're just about ready to talk about iterators. Just see, and I think we talked about insert, where you can insert at a particular place using an iterator. Here's a good one: resize and reserve. These two are related, but they're not the same. It's very important to understand. Now, you would probably use these at the beginning, because they have to do with telling the class how big to make the buffer, and or how many objects to make active. Now, if we do my PlayerVect dot reserve, this function should go ahead and reallocate the underlying array to however many you specify. Now this is going to change the capacity, the size of the buffer, but it's not going to change how many are active. So right here we're going to stop the program. We're going to start it back up. And if we look here, you can see that we haven't actually pushed anything back yet. So the size is 0, but our capacity is 100. So this can actually save you some cycles, some time, and make your code more performant if you go ahead and reserve however many objects you think you may need, or if you know exactly how many you need, then you can just go ahead and reserve them all. And then it'll make sure that it has enough space for those. Now if you send in a number that's less than this, like for example on the very next line we're going to say my PlayerVect.reserve, and we're going to say 90. Now if you think here that it's going to change the size of the buffer down to 90, you would be mistaken. It's actually not going to do anything at all. As you can see, the capacity is still 100. So it only goes in the bigger direction. It won't go in the less direction. Now this is something that resize also does not do, but it will change the actual size. What I meant by that last statement is that it won't change the buffer in a less direction. Okay, so resize. It's a cousin to reserve, only it actually changes the size as well. Oops, breakpoint. What'd I do? Let me figure. Okay, my bad. So when we resize, it's actually going to try to call the constructors. So we actually need to, just for an example, call this an int. And we're going to change our code to be ints. We can get this to work with player, and I'll show you that in a second. But for now, I wanted to show you really quick the inversion. Okay, now this should work. Now, as you can see, the capacity here, because we've recompiled, and so the reserve is now gone. All we've done is resized. Now the capacity and the size have now been changed to 100. Okay, so resize changes the size too, as well as the capacity. However, while you can resize to 90, it'll change the size in a downward fashion, but it won't change the capacity, just like reserve. As you can see, the size has been changed downward to 90, but the capacity is still 100. And what this did is it actually constructed, the first line here, it actually constructed 100 objects for us using the default constructor of int. And then here we changed the size, so it actually destructed 10 of them, and it didn't change our buffer on the second line. And now I'm going to show you the player version. Instead of int, we're going to have a vector player, and our name is still my PlayerVect. Here it's going to resize it to 100, and then it's going to resize it to 90, just like before. times I. And this will be automatically converted, but we're just putting this back the way it was when we had our player. Now without these two lines, it should compile. Okay, so there we go. But what we're going to do here is we're going to resize this array. But what it needs is it's going to try to call the default empty player constructor, but because we don't have an empty constructor, all of our constructors take in parameters. We need to actually give it a value that it can use for the constructor. So we're going to make a temporary, and then it's going to copy this temporary. It's going to use the copy constructor when it resizes the array for each one that it has to add. We're just going to use 1 and 1. And then we need to do the same thing here. And now this should compile. As you can see, we have a whole bunch of these constructed with 1 and 1. Almost 90, probably 90 minus 5 or so. I'm not sure that all of them are being displayed at the same time. Yeah, it looks like it. It's quite a few of them. As you can see, if I move this over, that it's a lot of 1s as I move up and down. And so there you go. That's resize. Alright, so I told you that we would cover iterators. We're going to do that now. We're going to construct some objects, PlayerVect dot resize, and we're going to give it a 20, and we're going to give it the object of copy 1.0f, 1.0f. Alright, so now we should have 20 players in our vector with an x and y of 1.0f and 1.0f. Now, this is going to be a lot of typing for one variable. But iterators are very nice and powerful. So we're going to use a vector player iterator. Now, every time you change or create a new type of your vector, like for example int, we would have to change our iterator to int or write a new iterator. And I'll show you an int example next. Now we can just call this iter. But we need to assign this something, because it's kind of like an int that you would create an int but not assign it a value. It has nothing in it, it's not really valid. So we want to go to the very first one. Just like you would start a loop at index 0, we need to start this at an iterator to the first object. And you can get an iterator to the first object of your array using my PlayerVect dot begin. Very simple. So now this vector right here returned an iterator to its very first object in the array. Now you can also get an iterator. We'll call this one iter end equals my player vec dot, and my keyboard is messing messing up a little bit. There we go. So this is how you get an iterator. We can name this begin. So we can get an iterator to the beginning and the end. So now that we have a beginning and an ending value, we know how to iterate over this object, at least logically. We haven't done it yet. But iterators are a class object whose sole purpose is to allow you to iterate over an STL collection. So we do for. Now we've already created our iter begin, but we could do that here if we wished. Now we're going to do while iter begin does not equal iter end plus plus iter begin. Now this should look fairly similar as this is our iterator. We have our condition for looping, and we have our plus plus here. This is how we go to the next object. So we're looping now, but we actually use our iterator object. And this funky looking arrow syntax to actually access the object that we're iterating. For example, if during this loop, this is the first loop and it's at index 0, this will be the same as index 0. And then the next time it loops, it'll be index 1, and then 2, and then 3. And we can access each one of those using this arrow operator. For example, I don't know why the keyboard is lagging. Anything I type is taking forever. So we can do iter begin x space iter end y and line. Come on, keyboard. Okay, so this is functionally equivalent to the other way that we looped over the array. So let's see this in action. Great. What did I do? Oh my goodness. Wow, that was stupid. Alright, I don't know how I put this in here. Iter end. I must have used IntelliSense and clicked the wrong one or something, or my keyboard was messing with me. But there is absolutely no reason why we would want to access iter end. Because that's actually not even a valid iterator, because it's pointing to the past the end of the array, or past the last object in the array. So this is actually correct. That was a mistake. Alright, so we have iter begin x, iter begin y. And if we replay this, and there you go. We resized to 20, we gave it a 1 and a 1 for each player. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So we've used iterators to iterate over this object. So it seems like a lot of typing, and it kind of is. You can use iterators on vectors. See, vector gives you a choice. You have many ways to iterate over a vector. But some of the other STL data types, such as map, list, you have to use iterators. And they are actually all the same or very similar. So once you learn how to use an iterator once, you know how to iterate over almost every type of collection in the STL. And if we were to switch this to another type, such as list, we wouldn't have to change much of our code. In fact, all we would have to change is this to list, because it would be a list iterator instead of a vector iterator. And then all of this would still be valid code. Even though our player vector is, our variable is called myPlayerVect, that doesn't matter, it's just the name, so we're still cool. And you know what, I'm just going to go ahead and show you that just real quick. I wasn't really going to talk about list, even though my keyboard is really doing something weird. Probably going to have to restart my computer for this. Alright, so we have included list. I'll give you a second to see. Pound include, the arrow, list, the other arrow. And this includes everything for list. Now we've been using a vector here. We can use a list. And as you can see, it's pretty close to the same way that you would use a vector. Now if we just change this and this, our code still works. Everything else, everything to do with the iterators is still valid. Even our resize is valid. Because everything in the STL that handles data types, like collections and storage types, whatever you want to call it, they all share a similar interface, even string, as you saw, and they all can use or have to use iterators. So if you write a lot of iterators in your code instead of using the index way, you can actually switch your data type later very easily. Without having to rewrite a lot of your code. So most of the time, what you'll be doing with a vector, we're going to go back to vector. Most of the time, what you're going to be doing with a vector is you're going to be stuffing some things into a vector using either pushback or InPlaceBack. And then you're going to be looping over your vector and then doing code on each one, just like you would an array. But everything is handled for you, so you can be more efficient. You can work quickly, because if you had to write this class yourself, that would take you quite a while. And you may or may not introduce your own bugs, but you know that this class should be bug-free. And it should be rather efficient as well, because it's had a long time to mature. Now, this vector class is more of a general purpose class, and if you get really good at programming, you would maybe eventually write your own type of dynamic array class that's very specialized to the needs of your particular application. That's up to you. But this will satisfy most of your needs, and it's a very quick and efficient way to store an array. So I think that pretty much is a pretty good introduction to a vector. I've showed you 3 or 4 ways that you can loop over a vector and print things out. I've showed you iterators, I've showed you different types of vectors, and you can put any type in here that you want, and that changes the meaning of the vector. Now this is a vector of players. We could make it a vector of ints, floats. Be careful with a vector of bools, because that's a specialized template class. So just don't use that one, and you would very rarely need to. You can use a char in here. But if you use a char in here, you've basically created yourself a vector of characters, which is an array of characters, which is very similar to a string and what the string class provides, although the string class has the extra functionality of being able to concatenate and things of that nature, things very specific to strings. So use string class for that. Now I just want to make sure that I didn't miss anything important. We talked about you can get the front, the back. This is the object at the back, the very end, the last valid object. You can get at a particular index using at or the array index. You can get the size of the underlying buffer. You can have front. This will give you a reference to the first object in the array. Oh, I wanted to show you erase. Okay. I don't want to do this line anymore. I'm going to loop for int I equals 0, I is less than number count. So this will loop over for however many times this is, which currently is 5. I'm going to do my PlayerVect dot. And then I'm going to push back I. And I'm going to make this an int. We're going to leave the name the way it is, even though it doesn't correctly describe it anymore. And then we're going to do the other type of syntax, begin inline. Now this does pretty much similar what the arrow syntax did, except for after you put these parentheses here and the dereference operator, you would be able to use the dot here. If this was still a player, we would have dot x or dot y. But since this is an integer, we're just going to dereference it. So this gets what this is actually pointing to, the index that the iterator is representing. So this is going to print out the integer at that index. Okay. Push back. Now, what this should do, unless I mess something up, is put in 0, good, 0, 1, 2, 3, 4. That's exactly what I wanted. Now let's increase this to 25. I don't know why. So now this loop's going to loop over 25 times, and it's going to push back the value of our index I. So it'll be 0 through 24. Now, what we're going to do is we're going to call erase, but we're going to call it on the one that has a value of 20. So we know that we've pushed in I, so we know that the one that has 20 should be the object at index of 20. So we're going to call erase. This is, again, just a method. Now what it wants is an iterator. One of these that we've already created. But it wants the iterator that points to the one that we want to erase. But we can use a fancy syntax here and use my PlayerVect.begin Now as you see, this will return, like we used it above, an iterator to the very first index. But we want the 20th one. So if we add 20, then it's going to give us an iterator to the 20th. So 0 plus 20 basically. And then when we, I want to put this up here so that after we've pushed them, but before we've printed them. So when we print them, it should skip 20 because that's no longer in the array. And here you can see that at index 20, the int no longer exists. And that's how you can get an iterator to whatever index you wish with a vector iterator. And it's also important to note that while we pushed in 25, after we erased one, our size is now only 24. So the size was subtracted 1. So I think that that's a pretty good introduction to the vector. And this is going to suit most of your needs. Almost every time you need an array, you use vector because it's templated, so you can use it with whatever class you want. And you will be doing this a lot. You create vectors a lot in programming, and they're very, very useful.